everyone, and welcome to Xiaohe Classroom. In this section, we introduce H312 as a communication operation for the S7 master station. Our main words are implemented through library instructions. So let's go directly to the program block and take a look. The program has been written. Let's take a look directly. S7 communication is mainly achieved by reading and writing to instructions. The instructions are under the library, and there is an S7 communication library under the communication class, which contains two instructions, S7 write and S7 read. Read and write operations to slave data can be realized using S7 read and write instructions. Instruction calls can call all read operations together and all write operations together. Then the instruction pin needs to give a start address pointer. The specific table meaning can be viewed at the instruction definition. The table definition of the read and write instructions is the same. Let's look at one. Below we can see the definition of each byte of the table. The first byte is BigInt. The first to fourth bytes are the Internet Protocol address of the slave. Then set the fifth and sixth bytes to 0. Then the seventh to ground 10 bytes store the location for the perimeter address of the slave station. For example, to access the address starting from station VBO, directly transfer the pointer of VBO to the two-word address starting from the 7th byte here. Then the following is the length of the data to be accessed from the slave, no more than 200 bytes. The following is the address pointer of the data stored in the master station. For example, which address of the master station do you want to write data to the slave station? Or which address of the red slave station is placed in the master station is set through this place. Then this is the meaning of BigInt in the 0th byte just now. So let's go straight to the program. Take the first write operation as an example. The table pointer is VBO. Let's take a look at its definition. The Internet Protocol address of the slave is stored from the first byte. Then write 0 on the 5th and 6th bytes. Then the 10 consecutive bytes starting from the slave station VBO are accessed through the address starting from the master station VB1000. So the VBO pointer is written to VD7, 10 is written to VB11, and the VB1000 pointer is written to VD12. Here is the table content definition for the second write command. Write data from 10 consecutive bytes, starting from master VB1500 to 10 consecutive bytes, starting from slave VB50. Here is the address where the 10 consecutive bytes starting from the slave station VBO are read to the address starting from the master station VB2000. The following is to read the 10 consecutive bytes starting from the slave station VB50 to the bytes starting from the master station VB to 500. Let's go directly to the state table and take a look. H36 is used here as the S7 slave. Just set the Internet Protocol address and the master station in the same network segment. Let's download the program into H312 first. Then we use H36 for the slave, and its Internet Protocol address is the same as what we configured in the master program. Then monitor the leader-follower data interaction directly in the state table. Write from VB1000 on the main station. Then read it to the main station's VB2000. You can see that the data has been successfully written and read to. In this way, we have realized H312 as a communication operation of the S7 master station. That's all. Thanks for watching.